Hello, this is part 2 video for class 12 organic chemistry lesson Haloalkanes and Haloarenes. 30 passing package questions with answers are given here. Part 1 video of 15 questions is available in my channel. Okay, now let us enter into the video. First question, explain Schwarz reaction with an example. When alkyl chlorides or bromides are treated with metallic fluorides such as AgF, Hg2F2, COF3, etc., alkyl fluorides are formed. So, general equation for this reaction is Rx plus AgF gives rise to Rf plus AgX, where R is an alkyl group and X is ClRBr. Pause the video and observe the examples. Second question. Explain Finkelstein reaction with an example. Answer for this is when alkyl chlorides or bromides are treated with sodium iodide in dry acetone, alkyl iodides will be formed. General equation for this reaction can be written as Rx plus NaI in dry acetone gives Ri plus NaX. Look at the example. Third question. Among an alkane and an alkyl halide of comparative molecular masses, which one will have higher boiling point and why? Answer. Boiling point of an alkyl halide is higher. This is because alkyl halides are polar while alkanes are non-polar. You must know that there is electronegativity difference between the alkyl group and halide group in alkyl halides, which makes them polar, and therefore intermolecular force of attraction in alkyl halides, that is dipole-dipole interaction, is more. Higher the intermolecular force of attraction, more is the boiling point. Fourth question. What happens to the boiling point of isomeric haloalkanes with increasing branching? Explain with an example. Boiling point decreases with increase in branching. This is due to branching decreases its surface area and molecule attains spherical shape, which weakens intermolecular forces. Example, isomers of chlorobutane are given here. Boiling point of 1 chlorobutane is higher than the boiling point of 2 chlorobutane. Fifth question. Arrange the halides Ri, Rf, Rbr and Rcl containing same alkyl group in the increasing order of the boiling point. Look at the answer. Sixth question. In isomeric dihalobenzenes, the para isomers have higher melting points than ortho and para isomers. Why? Answer. Because para isomers are symmetric in nature and fits in crystal lattice better than ortho and meta isomers. Look at the example given here. Boiling point of parachlorobenzene is higher than that of the metachlorobenzene. Seventh question. Explain Sandmeyer's reaction for the preparation of halohydrocarbons. Answer. It is the conversion of diazonium salt of aromatic hydrocarbon into halohydrocarbon in the presence of cuprous halide. Look at the equation of the reaction. Eighth question. Write the IUPAC name of the given compound and it is 1-chloro-2-methyl benzene. Ninth question. What is optical activity? The property of the compounds rotating the plane of polarized light is called optical activity. 10th question. What is racemic mixture? Give an example. Equimolar mixture of D and L isomers of the same compound is called racemic mixture. Example, plus and minus lactic acid or D and L lactic acid. 11th question. Racemic mixture is optically inactive. Why? Optical activity of one isomer gets cancelled by optical activity of another isomer. So, racemic mixture is optically inactive. 12th question. Write the order of reactivity of alkyl halides towards SN2 mechanism. Look at the answer. That means primary alkyl halides are more reactive towards SN2 mechanism. Next question. Write the order of reactivity of alkyl halides towards SN1 mechanism. Look at the answer given here. That means towards SN1 mechanism, tertiary alkyl halides are more reactive. Next question. Explain SN2 mechanism for the reaction of CH3Cl. Look at the mechanism given. The nucleophile OH minus attacks from backside. Therefore, the configuration of the molecule inverts. And it is a single step reaction, and therefore this will be the rate determining step. So it follows second order kinetics. 15th question. In SN2 reaction, transition state cannot be isolated. Why? Answer. In the transition state, carbon atom is simultaneously bonded to incoming nucleophile OH minus and the outgoing leaving group Cl minus. As a result, the carbon atom in the transition state is simultaneously bonded to 5 atoms and therefore it is highly unstable and hence it cannot be isolated. 16th question. Aryl halides are less reactive towards nucleophilic substitution reactions than alkyl halides. Give reasons. Answer. This is because, first point, resonance effect. Due to the resonance effect, the carbon halogen bond acquires a partial double bond nature, hence, higher energy is required to break this bond. Second point, hybridization of carbon atom. sp2 hybridized carbon atom in haloarenes is more electronegative and hence the bond becomes more strong, which is difficult to break. Third point, instability of phenyl cation. Phenyl cation formed by the dissociation of aryl halide is highly unstable and it is not resonance stabilized. Fourth point, high electron density on benzene. Each carbon atom in benzene is an electron rich center. Hence, nucleophiles cannot easily approach as there exists a repulsion which decreases the rate of nucleophilic substitution reaction. 17th question. What are enantiomers? Answer. Optical isomers which are the mirror images of each other are called enantiomers. 18th question. What is racemization? Answer. The phenomenon of conversion of an enantiomer into racemic mixture during a reaction is called racemization. 19th question. Explain SN1 mechanism of the reaction of tertiary butyl bromide. Look at the mechanism. This is two-step reaction. First step is the slow step. Therefore, this is the rate determining step where only one reagent is involved. So, this reaction follows first order kinetics. 20th question. Write general chemical equation for Wurtz-Fittig reaction. Alkyl arenes are formed here. 21st question. Explain Fittig reaction with general equation. Answer. Two aryl halides react with sodium metal in the presence of dry ether and form a diphenyl. Question number 22. What are freons? Give an example. The fluorochloro compounds of methane or ethane are collectively called freons. Example CCl2F2. 23rd question. What is a chiral carbon atom? Answer. A carbon atom bonded to four different atoms or groups is called a chiral carbon atom. 24th question. Explain Zaitsev rule with an example. Zaitsev rule or Zaitsev rule states that during dehydrohalogenation reaction, the preferred product is that alkene which has greater number of alkyl groups attached to the doubly bonded carbon atoms. 25th question. Write the general formula of Grignard reagent. Answer. RMgX, where R is the alkyl group and X is a halogen atom. 26th question. Explain Wood's reaction with an example. Alkyl halides on heating with metallic sodium in dry ether give higher alkanes. Example. 2CH3Cl plus 2Na in dry ether react to give ethane. 27th question. What is the effect of DDT in the environment? Answer. First point. DDT is non-biodegradable compound because it has low water solubility and high fat solubility. Second point. Large DDT residues remain in human tissues. 28th question. Why is the boiling point of ethyl bromide is higher than that of ethyl chloride? This is due to ethyl bromide has higher magnitude of van der Waals forces due to its larger size. 29th question. Arrange the following in the decreasing order of the boiling points. Look at the answer. 30th question. How do you prepare ethyl magnesium bromide? Write the chemical equation for this reaction. Answer. CH3CH2Br plus Mg in the presence of dry ether react to give CH3CH2MgBr, a Grignard reagent.